Hello everyone, today we will start with the study of sensors and their interfacing with Arduino. So objective of this particular topic is to student can able to interface sensor with Arduino. These are the hardware requirement for this particular topic: temperature sensor, 2 LED, 470 ohm resistor, an Arduino board, breadboard, jumper wires. These are the points we have to cover for this particular topic. First of all, introduction to Arduino, features of Arduino, in Arduino pin configuration, how to use an Arduino, then Arduino programming, heat sensor, then sensor interfacing with Arduino. Here, first, just introduction to the Arduino. Arduino is a prototype platform that is open source based on easy to use hardware and software. It consists of a circuit board which can be programmed, referred to as a microcontroller, and ready-made software called IDE. IDE stands for Integrated Development Environment, which is used to write and upload the computer code to a physical board. And next, let us discuss about the features. The operating voltage is 5 volt. The recommended input voltage will be range from 7 volt to 12 volt. Input voltage ranges from 6 volt to 20 volt. Digital input output pins are 14 pins, and analog input pins are 6. DC current for each input output pins is 40 milliampere. DC current for 3.3 volt pin is 50 milliampere. Flash memory is 32 KB. SRAM is 2 KB. ROM is 1 KB. Clock speed is 16 KB. Then after that, we have to study about the pin configuration. First of all, input and output. The digital pin on the Arduino can be used as an input and output with the help of the functions like pin mode, digital write, digital read. Pin 1 and pin 0. This pin is used to transmit and receive TTL serial data, and these are connected to Atmega 8U2 USB to TTL serial chip environment equivalent pins. Pin 2 and 3, external pins can be connected to active and interrupt over low value, change in value. Pin number 3, 5, 6, 9, 10 and 11. This pin gives 8-bit PWM output by the function of analog write. SPI pins. These pins maintain SPI communication even though offered by fundamental hardware, and is presently included within Arduino language. Pin number 13, that is LED. The bill LED can be connected to pin number 13 as high value pin. The light emitting diode is activated whenever pin is low. Pin number 4, it supports TWA communication with the help of wire library. AREF, that is reference voltage. The reference voltage for the analog input with analog reference. Reset pin. This pin is used to reset the microcontroller. Memory. The memory of this Arduino microcontroller include flash memory 32 KB for storing code, SRAM 2 KB, EEPROM 1 KB. Then next, how to use an Arduino Uno. Arduino can detect the surrounding from input, as the input is variety of sensors and this can be affect its surrounding through controlling motors, light, other actuators. The Atmega 328 microcontroller on the Arduino board can be programmed with the help of Arduino programming language. The IDE Arduino project can communicate by software while running on a PC. Now next one, pin configuration of LM35. In this experiment, the Arduino will measure the temperature using an LM35 sensor IC. The LM35 is a low voltage IC which requires a power supply from plus 4 VDC to 20 VDC. This is ideal because we can power the sensor with the help of Arduino's plus 5 volt output. The LM35 has just 3 pins, 2 for the power supply and 1 for the analog output. The output provide an analog voltage output that is linearly proportional to the temperature in degrees Celsius. The output ranges from 0 to 1.5 volt when the powered with the single power supply. An output of a 0 volt corresponding to temperature of 0 degrees Celsius, and the output increases 10 millivolt for every degree increase in the temperature. To convert the output voltage, you need to only divide the output voltage in millivolt by 10. For example, if the output value equal to 315 millivolt, the temperature is 31 degrees Celsius. Now this is this interfacing diagram. Arduino with the heat sensor. After that, we have to discuss about how to implement this experiment. Make the connection as per the above circuit diagram in Tinkercad software. LM35 output pin is connected to A0 of this Arduino. The code uses the function analog read to convert the output voltage to number between 0 to 1023. Multiplying this number by 0.848828125 converts that value to degrees Celsius, which is then displayed on the serial monitor. This is regarding the experiment performance. In the next video, I will explain you how to perform this experiment using the Tinkercad software. Thank you.